All right. Hi, everybody. It's Rob. Welcome to AWS Step Functions. Today is a little bit bittersweet for me. It's the last episode that we have planned in the series, but it's an interesting one on nested workflows. So the final thing that we're going to do, at least for now, is learn how to invoke Step Functions workflows from within Step Functions workflows. So again, thank you all for joining today and throughout the series. Here's a quick overview that you see on the screen of what we're going to do. What are nested workflows? We'll talk about specifically how you define them, why you would use them, and when you would use them. We'll talk about the different invocation types, and we've talked about this before, but it's more or less fire, forget, synchronous, and asynchronous. We'll talk about the different workflow types, so standard workflows and express workflows, how they work together, which ones can invoke the others, etc. And then we'll talk about special considerations for handling errors in nested workflows, and then we'll build. So for today, since it's the last episode, I want to maximize that build time. I'm going to go through the talking bits pretty quickly. But I do hope you'll stick around until the end, because there's a feature that just launched as we were playing the demo music that I want to show you. So stay tuned to see that. You're definitely going to want to be aware of this if you're building nested workflows today, or if you intend to. So with that done, a little bit of talky from me. What are nested workflows? Well, I answered that when I gave you the definition. It's whenever a step functions workflow invokes another step functions workflow via service integration. And we've done an episode on service integrations for AWS Step Functions. Previously, it's in the playlist. This is just another service integration, just like DynamoDB or invoking Lambda functions or sending messages to an SQS queue. The reason that we would use a service integration for step functions or a nested workflow, there's a few. First, there's composability, right? So if you have building block tasks that you perform across workflows, maybe with different inputs that return different outputs, but it's the same process and the same task, and you find yourself rewriting or reusing it, well, just like any programming, the whole dry, do not repeat yourself thing, right? This allows you to write it once, deploy it once, and then invoke it from those other workflows. So you know that it's a stable, defined process. You're not reinventing the wheel. You're not potentially introducing errors into your workflows. And then that hits at the second point, which is reusability. So once you've written some sort of abstraction for a part of your business process that's shared across business units or within your business unit, you get the advantage of reusing that investment in time. And sort of an underrated one that I like is simplification of your top level workflows. Every process becomes a little easier to reason about as you can eliminate other processes off the screen, right? Like I forget what the saturation point is. I know it's somewhere south of 200, where once you're looking at 200 objects, you can't really understand what's going on with the process. But if you can break that down into 10 major processes, and you see this at companies all the time, right? In fact, they're typically numbered under a controls framework. If you have a major process and then you have nested minor processes underneath it, that same model carries over here so that you can have your billing event process and then the individual minor processes underneath it, sub processes underneath that, as deep down as you want to go, subject to the constraints of the workflows that you're using. Okay, so that's typically when you would want to use those. If you have a lot of repetition, or to simplify the reasoning, or if you have distributed ownership of processes within your company or your organization. The different invocation types. Again, if you go back to let me drop this links command in the chat for y'all real quick. If you go back to it says series playlist there, robsutter.tv/SFN, you'll see an episode on service integrations. That's also linked directly here, as you see the little Twitch icon come up, or the video thumbnail come up. We did an entire episode on the different invocation types. Some of them are a little more difficult to see the difference. Some of them aren't available for all three services, but with step functions, it's available for all three services or all three invocation models, and it's really clear what the difference is. So today we're going to build a request response, commonly known as fire and forget, and we're going to build a synchronous or the run a job is the proper name for it, or synchronous workflow invocation. I'll show you the differences between the two. And you really need to pay attention to them here, because with step functions, nested workflows, the difference matters a lot. You will get different outcomes. We're going to demonstrate that while we build. But the third type of invocation is wait for a callback with the task token, or the .wait for task token parameter. We're not going to build that today, but we do build that in that episode that I've linked to here for you in the channel. So I'd encourage you to check that out if you haven't already seen it. That essentially creates a token in a standard workflow that goes into the task, and the task then calls back to step functions on completion with that token. So that can be a manual stop point for human interaction or approval. It can be a long running task, something on premises, something even, where you've got to do an air gapped transfer and bring some data back. Tons of potential uses for that. But we're not going to build it today. So I'd encourage you to watch that episode if you have questions about that, or ask them in the channel. Again, since this is the last planned episode, I would encourage you to get all your step functions questions out now so that we can get them addressed. All right. Side fun note, my can is green, which I didn't really put together, is going to wind up disappearing on the green screen. It's not related to step functions, but it made me happy. So different workflow types. There are two different types of workflows in step functions. There are express workflows and standard workflows. And standard workflows, if you have been building with step functions from the beginning, that's what's always been around. They're long running. They can run for up to a year. And they have, because of that, they have a lower invocation rate and a different model around execution. They're exactly once execution for each of the states. Then we have express workflows, which were introduced at the end of last year, which, as I've said, I've opinionated in previous episodes. If you can fall within the constraints of express workflows, you should always be using them, because you get more concurrency, you get faster execution time, less latency. But that constraint is that it needs to complete its execution within 5 minutes. And in fact, you get some aspects of express workflows here where you don't want to invoke a standard workflow from an express workflow, for example, because that standard workflow could run for up to a year, and then you'd be dealing with a timeout in your express workflow, even though it wasn't necessarily a failure. So that sort of gets us into where to use which. The pattern we're going to build today is a standard invoking multiple express workflows in a parallel state. That's a pretty common pattern. It's also a really common pattern to invoke an express workflow inside of a map state, or dynamic parallelism, where you have a collection of items that you need to iterate over, but you're applying a complex process to those items. I would argue that that should be your default way of thinking about dynamic parallelism today, right? Is you want to wrap that in a workflow so that as it expands, you can expand the workflow instead of trying to chain things together in a brittle fashion. So that's where you would typically use them. And then the rest of it you can sort of logically devise, right? It makes sense for a standard workflow to call nested standard workflows. You may have a process with multiple manual approvers, right? It needs to be approved by legal, it needs to be approved by purchasing, and those are both manual processes. So those will take more than 5 minutes. And then the enveloping parent workflow necessarily needs to work for longer than 5 minutes. Do I have a diagram for that dynamic parallel super duper workflow thing? I do not, but I think, thanks Matt, I think we could actually build one right now. Let me jump to that in 2 minutes. It'll just take me a minute in draw.io, and we'll get that and we'll leave it in the source code for you after the episode. So calling standard is pretty clear. Standard calling express is pretty clear. That's the example that we talked about for dynamic parallelism, or for map states, or for parallel states that we're going to build today. Express workflows can also call express workflows, but you really need to be clear on your timing considerations. If your nested express workflow runs for 5 minutes or longer, well, it won't run for longer, but if it runs for 5 minutes after some other execution in serial, then your parent workflow is going to time out. So you'll probably want to limit the execution time of those nested workflows in that case. And then never call a standard workflow from an express workflow for what we mentioned. Before we go to handling errors, we'll deal with handling errors while we build, because that's where it comes up. I'd like to address Matt's question here, which is an example. Oops, helps when you do things in the right tab, right? Which is an example of super duper cloud. We can delete all those things. I'm not going to use the service icons here. All right, we're just going to use this rounded rectangle to represent our entire workflow. And we start with endpoint, or we start with a start point, and then we have an endpoint, right? But inside a dynamic parallelism state, which we've also done episodes on, there's a parallelism episode that shows you, and it's available in the series. The parallelism shows you when to do it via the parallel state, when to do it via the map state, and when to do it via parallelism or concurrency inside a Lambda function. So if you're not familiar with that, I recommend you go back and check that episode out as well. For those of you that don't know, where do I get my properties here? Edit style, nope. I'm sure somebody smarter than me will know this. We'll just have to imagine it. I'll build one for you and we'll show you what it looks like in the console. Can I zoom out, move all this stuff down a little bit? Here we go. And then if we copy this, and we can just imagine that this is an express workflow, right? So we get ourselves a little bit of text. This will be an express workflow. And this will be a standard workflow. And let's say that you're doing batch processing, right? And so a bunch of credit applications come in over and you process them for whatever reason on a spot instance, right? They don't have to be done right away. You wait until you get a spot instance available. It's available, so you stand up the pipeline. Props can be found via the icon to the left of the double chevron on the top right of the working pane. Pow. Thank you, Big Dub 2491. Appreciate you. Okay, so this one, I do this to match the console. That's why. Because in the console, it'll look like that as a nested workflow. So let's say we've got our spot instance, and now we kick off this workflow. The first step in here would be something like, you know, turn on spot. And then once that's ready, we do something like, whatever we call this, drag this down here just to get it out of the way. Process request, or, you know, credit check. And we can say that the credit check is a fully automated process that we know will complete in fewer than 5 minutes, even with retries. And so then we maybe like manual review if necessary, right? And so this, if we have the manual state, that's why this needs to be a standard workflow. This and this should be back over here this way, right? But this credit check is actually going to be the entirety of this workflow, right? And this can be via parallel states to all 3 credit bureaus if you're in the US, or your own internal holdings plus a credit bureau call, however you need it to be. But it should all be expected to complete within 5 minutes. So each one of these credit checks is for each item that came in the batch is executing through this workflow. So you might build it as just, well, we only hit a third-party bureau, so I can do this as a Lambda function. Well, you can, until you gain access to some sort of specialized repository that you need to also call, and then you're better off having the workflow there in the first place, right? To manage and orchestrate all of the calls. So first party. Does this make sense, Matt? Each of these is a step functions workflow, but this one on the left as a standard workflow has some manual reviews and is going to run for up to a year. It consists of a collection of items, and each of those items is going to have this express workflow executed against it, and then it's going to return its data back to here, and then it's going to proceed through the workflow. So good. Glad the diagram helped. Let's look at some code, because what we have left is to handle errors inside the nested workflows and to build. So we're just going to jump into building and look at handling errors as we go. Again, love this state machine. I'm sorry, the AWS Step Functions integration for the AWS Toolkit for Visual Studio Code, which we covered in the first episode that kicked off this whole series. If you haven't seen it, check it out. We're using it here for some of the tooltips. We're going to create a parallel machine here, and we can visualize it so that we see, hooray, this looks like what we want. Let's eliminate this wait state, just so that we can get a little cleaner. Ultimately, we're going to go into building this in SAM, but we're going to build each of our state machines using this visualization and then pull them into the SAM template. You see that lovely little green nested workflows complete? Don't worry. When I get hung up on some mistakes, we're going to go in there and steal the code. Because I already did it. Ooh, invisible. Oh, the window's not right, y'all. But I have invisible sparkling water. Okay, so I'm going to make a very simple fake state machine for us to test. And I'm going to show a couple things in here. We're going to have start at, so we know we have, actually, let's go back to our diagramming tool since Matt's right. That stuff makes for easy visualization. We're going to have a parent workflow and two child workflows. So this will be the parent. And we'll have a child that always fails. We'll call it like failing child. And we'll have a child that always succeeds. And this lets us see succeeding child. And this lets us, excuse me, y'all, I'm gonna have to sneeze here in a minute. I got the mute button this week. Don't think I didn't notice your CDK folder. That's not my CDK folder. That's Richard Boyd's CDK folder. I know very little of CDK, unfortunately. Not as a... I could name those second child and first child. I'm not sure if that's dark humor, but I get it. I'm a third child, though, so I'd be off, like, somewhere off screen doing my own thing. Anyway, so we're going to have this workflow. The parent workflow is going to start. It's going to invoke these two child workflows in parallel. And this is different from the dynamic parallelism that we just discussed. All right. This is whoa, not to back. Okay. You all the way to back. This is the parallel state, which is when you do task A and task B at the same time and wait for them to complete. Dynamic parallelism is the map state that we just showed, which is when you do task A against an entire collection of items. So you're a second child. That's why you wanted to be the succeeding child. I got you. And then we'll have end, right? So start, end. We'll call this failing child and succeeding child. And so, of course, this parent up here is a standard workflow. I need to make this bigger. And these two will be express workflows. So I'm doing this just so it's really clear what we're building today, right? Express workflows. Succeeding child. There we go. Okay. So we're gonna cheat because good creates great steals. And all we're gonna do is put a simple fail state here and a succeed state here. Because all we're concerned about is the fact that we're calling a workflow and handling the response from it. I'm a failing child. You're not though. You're not though. I know your work. You're a succeeding child. So all we're doing here, it doesn't matter to this parent workflow whether these have 1 state, 5 states, 100 states, their own nested workflows, whatever. All that matters is that they're going to pass an input object on this invocation as one of the parameters, and they're going to receive an output object back at the result path, right? So everything in between is irrelevant, which means that we can mock entire complex workflows just by one of two outcomes. They either succeed or they fail. So with that done, should be pretty clear what we're building. Let's go back. So So we want 2 branches. Type parallel next final state. Yes, this branch will start at the failing state, and it will be a failing state of type fail. Love that auto completion, because now we also get the other properties that I always forget. Cause, what's my tooltip here? Provides a custom failure string, right? So child dot failure dot, let's call it undefined failure, right? Error provides an error name that can be used for error handling in retry catch, right? So we can just again use this. And comment, a human readable comment. So this causes the state to fail with an undefined error. Okay, we have not, this is not in a workflow yet. Diagramming pseudocode is awesome. Thanks, Julian. Y'all, if you have questions, ask Julian. The guy knows what he's talking about. He's one of my colleagues. I appreciate his help today here. This causes the state to fail with an undefined error. So you'll notice right now that we haven't defined separate workflows. I'm going to define this all inside the standard workflow, build and deploy the standard workflow, and then come back, break those out into express workflows and invoke them that way. Hopefully without ever going back to my code, but y'all know how that goes. All right, and then in here, we'll need to start at succeeding state. This will be succeeding state. Sorry, let me see if I can move this out of the little, there's a command to move that. I may have to go in, yeah. All right, let me just move that for you. Succeeding state, type. Can y'all hear my cat? So much noise. Succeed, so much noise. She wants to get into woof woof, dude. Oh man, you're bilingual. You speak woof woof and meow. That's crazy. Type succeed. Let's see what our other comment. Put a comment in here. Sort of go parallel with this one. This causes the state to succeed. What else do we have? Input path and output path. We're not really concerned with those right now for the success state. Ultimately, we will be when I show you that new feature later. So stand by. Yes, Augustus, writing in JSON. YAML would be much better. It would be, and I love YAML with all of my heart. And people that don't like YAML don't understand YAML well enough. How about that? I love YAML. The ASL currently supports JSON. It's written with a JSON syntax. It's a domain language in JSON. If you use the serverless framework, you can define them with there's a plugin that allows you to define state machines in YAML for the serverless framework. But for now, you know, we go to Twitch with the tools that we have, not the tools that we wish we had. So we have succeeding state here, final state, pass. We have this hard-coded little workflow here. We'll render that graph again. I didn't need to close that. It automatically updates. And we see this is pretty much what we talked about. That final state we don't need, but let's leave it in there and let's update our diagram instead. Just because that's what I had before, and so if I go messing with code, might not actually end well for me. And then we'll have this final state that executes no matter what. This will actually help us visualize our error handling. So for right now, we don't have failing child workflow, we have failing state. And we don't have succeeding child workflow, we have succeeding state. And all of these things over here don't exist yet, okay? So let's use the space bar to move those. Okay, here's where we are, happy. Now what do we need to do? We need to get a terminal here. Okay, and we need to, that's not a directory anymore. So sam init. I use Go. If you use another language, that's super. We're actually not gonna write any Lambda functions. This is like hard coded into my head to do this way. First thing we're gonna do is delete that Lambda function that it creates for us. I just do this to get a valid CloudFormation template and the deployability that comes with using SAM, right? So you don't have to, I'm neither in a module nor my Go path. I am aware of that. Thank you. Very helpful message. Okay. So like I said, first thing we're going to do, we're going to delete that. No code, no make file. Although I will go back later on the recommendation of a loyal viewer, a recommendation I very much appreciate, and add some make files to this code to make it easier to deploy these templates. And then in here, it's not a sample workflow. We'll do some cleanup in here. If you're not familiar with SAM, then you probably haven't seen any of the other episodes of this series because we use it for a lot of them. It's basically a CloudFormation transform. It's a macro. So whenever you run SAM, it gives you some special features. Thank you, Julian. That's exactly right. It's the AWS Serverless application model combined with a SAM CLI, performs that CloudFormation transform, generates bone standard CloudFormation, and spits it out. The difference is you can do things like my table, type AWS, and you get this serverless series of macros. And so we have simple table. That's all you need to define a DynamoDB table with on-demand capacity, right? So it becomes like a 20-line explanation instead. So that's why we use that. Now you get to watch me fumble because what we want to build is, I'm gonna copy this code, y'all. It's not really worth this parent workflow down to here. Just down to here. So a couple things that we notice here. We're building a step function state machine. We have not given it a state machine type express. So by default, it's going to be a standard workflow. So this is going to be a standard workflow. I'm going to put this in here so we can talk about this real quick. So this is sort of like the magic incantation for writing a state machine inside SAM or CloudFormation today, right? It's just sub, which is a built-in function, which takes two arguments. One, a template and a template string, and two, a map of key value pairs for replacements in that template string. So you can do stuff like name, Twitch. You have message. It uses $brace templating. And you get rid of one of those and we can say message, hello, that, right? And so when that sub is executed that you see here, hello, you'll get hello Twitch, right? Before it gets processed as a CloudFormation template. So that's all we're doing here because as we add our nested workflows, we'll be able to put those ARNs in by reference. I'm gonna bring this down here and comment it out for now, because if you only have text that you need to put in, you can just do this. And so for this definition string text, we will put the body of our state machine that we just created, right? And so that's just everything inside the braces only because I already put a set of braces there. Let's see if I can align this real quick. Okay, I think for there, it'll be good enough. I'm not going to deal with all the individual ones unless it makes me. And so what we've done here is just copy paste that parent workflow that we built right into here. And now since we did it in SAM, we can do SAM build and SAM deploy -- guided the first time. That'll walk us through deployment. How are we doing on time? 2:29. This is great. This is great. We're going to hit it. All right. Nested workflows. Again, if you have questions over where we are right now, please let me know. Otherwise, the next thing we're going to do is move these into, oh, I didn't give it a role, so that's going to fail. That's fine. While that waits to fail, yeah, just like that. I'm gonna go down here, back to the one that I already wrote, parent workflow and IAM role. Here's our role. Right now it doesn't do anything, so we're not gonna bring anything in. We're just gonna give it an empty role. Which should be there. All right. We've already done that setup for Sam. So this will probably give me the stack is in a whatever error, and I'll have to go delete that. I do this to myself all the time. Every time I deploy stack for the first time. Oh no, I guess it didn't try, which is good, which is what we want. So it's creating that role, creating the stack. Inquiring minds need to know, what am I drinking? This is, I don't know if you can see, look at the colors. It's crazy, isn't it? It's key lime flavored. I don't know if I can say the brand name on air. I imagine I can. Uh-oh. Schema validation. End is not supported at there. So let's see what I've done here. But it's, sorry. Yeah, it's the crop. Well, now I said it out loud. Thinks I missed a brace at the top of the step function. Probably. It's key lime flavor, though. This is the important stuff. Key lime flavor is really, really good. It's like naturally a little sweet. Same with limoncello flavor. So check those out if you have not yet. And true, this causes this to fail. Well, let's go back over here and look, because this doesn't have any errors in it. Let's see, end is not supported at states parallel branches 1. That's succeeding state. Type succeed. Oh, yeah. All succeeds are ends, as are fails. So, don't want to save that yet. I just changed that in the wrong place. We can get rid of that failing state. Now we can do this. Now I need to, what did we call it? Nested workflows. That's a custom command that I built. It was originally CFDS for CloudFormation delete stack, but that's incredibly awkward to type because of how you have to do this like in to out finger. So I made it GFDS on the recommendation of somebody on Twitter. I like those indent highlights. Might need to grab that extension. Agreed. Hi, M. Shay. Thanks for joining. Would your visualizer help find that error in syntax? It would and it should. Let's see why. I'm curious as to why it didn't. Oops. Oh my gosh, y'all. I'm just like pushing buttons everywhere. I clicked the wrong thing. Succeeding state. Who knows? Maybe we found a bug live on Twitch. Who knows? I'll have to go back to the ASL docs and check out if that is allowed. Where are we? Over here, type. So if I do, yeah, it doesn't give me the end option here. Whereas, if we were to add another state here, like a pass state, and go in here, and it has next instead of next, we could erase that. And yeah, this has end. So it gives me the hint because it's not a property that's supported, but for some reason it didn't drag it out. Yeah. Interesting. It didn't say that it was an invalid property. So, interesting. At least our stack is done now, so we can check over here. Sorry, somebody had a comment on the indent highlights. That is, I use rainbow brackets, which is for the brackets, and indent rainbow, which is for the indentation languages. Over here in the AWS toolkit now, we see we have this parent workflow. We can start an execution. And we'll go over to the console to check out the results. These other three are in here from my App 2025 series. They're dumping millions of transactions into an S3 bucket so that we can analyze them with Athena serverlessly on Thursday. Join if you haven't been watching, if you want to know how to analyze your data without running a relational database, or how to use S3 as your relational database, basically. All right, so we have a failed transaction here. All right, let's see what happened to us. Failing state, and we didn't handle the error. Well, that child.undefined failure. That makes sense. We should expect to see a failed transaction here, right? So let's quickly add a retrier. in here. I'm going to do this from my predefined workflow over here because I want us to be able to catch those failures and then continue on. So this is actually a task. Let's migrate everything out to the child workflows first. All right. So if we go back over here, I need to close some stuff so we can see what we're looking at. We've got this definition of our parent workflow and its role, and that's it. So now what we're going to need to do is bring in failing child and succeeding child and a no-op role, okay? Because we're not going to actually invoke anything, so they don't need any IAM permissions, right? So what we can do is just copy this role that we've already given ourselves. And you see, the only thing that we have here is step functions can assume that role, so we're done with that. We want our state machines. Let's just grab this whole thing and then we'll chop it up. For our failing child, we're going to call this the failing child workflow. There is a state machine type express. And we'll give it the, what did we call that? No op. Should have, did not. No op workflow role. So now it's an express workflow. Start at, we can cut this out all the way to here. Start at failing state. And all the way down to here. And then because of rainbow brackets here, I can see that I've got the right number of brackets there, which is always good. Okay, so we've pulled this out as its own state machine. Let's just go ahead and deploy this to make sure that we've got the right syntax. We haven't changed our parent workflow yet, so nothing is going to change if we were to execute this again. Got a couple questions for you. What's the benefits of nested state machines? Does it pass the input of the parent function? What happens if the child function fails? How about having a lambda that starts another step function execution in the original state machine? Okay, so we talked about the benefits of the nested state machine earlier. It's composability and reusability and simplification of complex workflows. So if you have different business units that own different sub-processes, you can still compose those into a major process. Does it pass the input of the parent function? No, it passes the input you give it, just as any service integration does. So you define inside parameters, and we'll do this in a minute, what it passes. What happens if it fails, we'll get to that. And how about having a lambda that starts another step function execution in the original state machine? You're just paying for an extra lambda function invocation. There's no benefit to doing that. I would call that an anti-pattern, because all you're doing is giving an opportunity for things to go wrong in dynamic code, which can have dependencies, vulnerabilities, which can age out, the runtimes change. Whereas if you put it inside step functions, it's declarative. You've got the service integration there, it goes. That's that. Some more info. Yes, thank you, Julian. And also in links, which don't seem to be hitting automatically, but there's some other information in links. And then we'll build out answers to the rest of your question. So awesome, back over here, we see we have a failing child workflow and we can execute that and it should fail as we'd expect. And while it sits there failing, let's build our succeeding child workflow, which is just gonna be the same thing, but tweaked a little. Again, it's a no op because we're not doing anything other than returning a success. So I can copy this state out of the original succeeding state machine. Replace that. Ta-da! Looks like I may have... No, I just out-dented too far with that one. succeeding child. Let's try and deploy this again while we go back and check on the outcome of our new state machine. So now we can see failing child workflow, express, hooray. We're actually not going to see the outcomes here. It's an express workflow, and I did not configure logging. If you want to see how to do that, go back to, there's an episode in App 2025 that shows you how to configure logging for express workflows for short running tasks. I believe it's episode 2 of App 2025, which is linked here in that links command I just gave you. So since the succeeding and failing workflows are both express workflows and we didn't enable logging, that's just what they're going to look like. All right, so we can close this for now. Refresh this and we have a succeeding child workflow. We can start an execution of that. Same thing, right? But again, we won't see anything, so we can move on from here. All right, so now that we've done this, we need to actually wire up the, in fact, let me delete that. I'm going to prove something to you first. I'm going to replace these as standard workflows. So this will be standard workflows, invoking standard workflows. And the reason we do this is so that you can see that that state machine execution is actually failing. But I want you to see what happens with the response object when it comes back in. So as that deploys, I hope that works because we're going to have to delete the old one and create a new one. No. So I'm going to need to, I'll delete this whole stack first and then just recreate it. This is trying to do it with the same name. Any other questions from my people in my chat? No, okay. If this ever finishes, we can start wiring up. In fact, I'm just going to do that. Oh, there we go. Update rollback complete, delete complete. Thank you. Nested workflows. Ta-da. Then we'll come back and deploy this again in a minute. All right. So if we go back over here, and because of time, I'm going to cheat and look at this. The failing child will replace this state with the task and all the retry and everything. Down to here. So bear with me because this is probably going to require some indentation adjustment. And then we'll talk about what we've done and why. All right, so we want to get rid of failing state, which is currently a fail state, and we want to replace it with a task. And other than giving it a couple extra braces, it looks like I did that. So let's just make sure, we'll get rid of states, that's why. States start at failing child. So now you see the difference. We've gone from that failing state to this failing child workflow. Let's focus in on this right here. I actually need to take that out. This is the first method of execution that we have for a step function service integration, right? This is, we talked about the 3 methods. There's the request for response or fire and forget. There's run a job or sync and wait for callback with a task token. This is request response. And what it does is it kicks off the job and then just goes on about its business. It takes the, more specifically, you can think of it as executing the API call to start an execution, and it receives the start execution response object, right? So that's going to have some implications for how we think of this. This is all formatted correctly. Task failure, fallback, that. Looks like I missed. All right. Y'all, this may be tricky, so I may, yeah, there we go. This all needed to go in one more. That's why. Okay. So we're going to deploy this one using the same settings we already had. Yes, we are streaming at the same time as, I can say their name, it's fine. It's Microsoft. It's Microsoft Build. So I thank you all even more for being here with me. And don't forget, little announcement coming at the end, so stick around. So we've left the succeeding state as an individual state, right? but we've changed the failing state to a workflow with that fire forget. Uh-oh. Was expecting double quote to start field name at, okay. So to rescue myself in this situation, I'm gonna take all this code out and cut it with what I know works. And then unbuild some of it. There's the failing child workflow. Here's our big policy. Here's that. Oh, that's why. So what I had done, we invoke this ARN, but remember I was talking about the sub command. I hadn't given it the information to replace it. So it was looking for a failing child workflow ARN down here in the substitution block. And I hadn't given it one. So, and I also hadn't given it the sub command. So that was just a bit of a mess on my part there. So instead, let's go ahead and deploy this as is. The difference that you're gonna see here is that I've gone ahead and implemented the succeeding child workflow as well. So two things that we had to do. One, we had to implement that substitute functionality so that we could pass the workflow ARNs by reference. And two, we had to modify our IAM role here. We had to give it a policy that allowed it to do the states start execution command on these resources, all right? This stuff, we're gonna come back to in a minute, isn't necessarily required right now because we're not doing sync invocations, but we'll come back to that whenever we modify this here in a second. So we'll delete this and redeploy. And while we're doing it, this section I want to talk about. What happens when you do a synchronous invocation is Step Functions needs to put some information somewhere so that it can look for completion of that task. It doesn't need that when it's doing the request response model, and it doesn't need that when it's doing the wait for task token model, because it already has its own token in the state object that it's maintained for the second one. And for the first one, it just makes the call, waits synchronously for the result of the API call, which is not the result of the workflow, and then moves on, right? So in this case, we need to be able to stop execution and describe execution of those nested workflows. And we need to be able to create targets on the event bus that are given a very specific name. This is in the docs. So when we go back to links, all this stuff comes from the documentation. If you go inside Step Functions, SI, Service Integration, that link there. All right, so here we should be able to put these back up. So right now, because these aren't synchronous, I can send them up that way. And then we'll wait just a little bit. Any questions from anybody? La Bulbul Divine. Is that like, it says Bulbul. You know, Bulbul is both Turkish and Arabic for mockingbird, which is got a beautiful song. Bet you didn't expect to learn that today in the AWS channel. Oh no. Oh, y'all. Do you see it? Do you see it? I didn't save my file. So we just deployed the same thing again, which is fun, but not really. So we're gonna have to wait another lap on that. You know, you tempt fire whenever you build live. Tempt fire? Tempt the gods, play with fire, however you like it. Get rid of that. All right, go up here, save, save, save. I'm just gonna copy this whole thing in from here again. And I just wanna go take out these dot syncs. Instead of messing with stuff. And then if this doesn't work, I'm just gonna cry on camera. You know, I'm not above it. Because we're almost out of time, so That'll be your entertainment for the rest of this episode. And then I'll give you the feature launch, and then it'll be the weirdest episode of AWS Step Functions that we've done so far. Although, again, sadly, expect it to be the last. So I want to go back to the question because we've got this in here now. Does it pass the input of the parent function? Let's take a look at, this is the failing child workflow. We'll skip the retriers. We got the retriers and the catchers there. If we're looking at this workflow, this is the resource ARN that we invoke. And again, one of the parameters is this input object. So you build this exactly the same as you would build any other, I'm very nervous. Okay, it worked, thankfully, it worked. So you build this exactly the same way that you would build any other path object, which we also did an episode on. So if you're unfamiliar with input path, output path, result path, and manipulating JSON path in general, please check out the series playlist and look for the JSON path episode. But here we see we succeeded. Let me see, did I make these express workflows? I probably did, which is gonna make me angry. No, I did not. I don't know, did I? I did. All right, I'm not gonna do a redeploy right now. You're just gonna have to take my word for it that the failing one fails and the succeeding one succeeds. And then we'll go back from there because what happens next is what's important. So we look here and we start an execution of our parent workflow with no input. And we can go back to the console, the AWS management console. We trust you. Thanks, Rundex. You should always verify those, so you'll get the code yourself. And we'll change this here in a minute. Parent workflow, we have an execution here, and it's succeeded without going to the fallback. Why? That's not what we would expect, right? And this is where I said it's important to know the difference in request response and run a job in nested workflows. Request response, if you're familiar with the AWS SDK, it's the same thing as you create a start execution input object, execute the start execution API call, and receive the start execution output object, which is similar. It's an asynchronous task, basically. It makes the API call and it gives you back information about your execution, like the identifier, the date, time started, etc. It doesn't give you any information about what's happening in the execution itself. So as soon as we kicked off this workflow, we went on about our business, and all we are representing here in this graph is that starting the failing child task succeeded. And we can prove this to ourselves by looking at the output. We have that empty input that we put in, and then the output gives us this execution ARN, the request ID, timestamp of the start date, right? No response data from that workflow. And if we look back at the workflow definition, we would expect to see this error info object being returned, right? That's how failure states work. They have to have that failure and they have to return it. So what happened here? Why didn't that work the way we wanted it to? Well, again, it worked the way we told it to, which is to use that request response model and not to do a synchronous invocation. So what we want to do for both of these is to change those to the run a job pattern. And when we do that, it's as simple as adding .sync. And always be wary when somebody says simple. And that whole stanza of IAM permissions that I showed you down here, right? But again, this is copy pasted from the docs. So this is something that's there for you to get, including like this whole rule name is very specific. That's in the docs, y'all. So just know that you need to modify your role when you're doing run a job. And then you add .sync and .sync here. So I was talking also about this. This is the input object that we've defined. This is an execution ID, which allows you to link those nested workflow invocations back to the parent workflow. So the nested workflow itself can have information about the invoking parent workflow by accessing this object. And you know where I got that? I got that from the docs. So thank you very much to the AWS Step Functions documentation team for putting that into the docs as well. So the changes we've made here are just to add .sync to these executions. Let's deploy this and let's take a look at the difference in the output that we receive. While we're doing that, what we should expect to see here, and I'll shorten this for the next deployment, is that this executes once, fails, waits 20 seconds, executes one retry, fails, waits 2 times 20 or 40 seconds, executes a second retry, fails, and then gets caught with this task failed error and sent to the fallback, okay? So if you don't understand how catchers and retriers work, that was last week's episode, error handling. Retread, I probably said that. That would not be the most ridiculous thing I've said this episode. I meant retried. Maybe I'm just, oh, I get you, past tense of retried. Yeah, today I retry, yesterday I retried, many times I have retrad. Past participle, active, I think. That's not what y'all are here for. So we've got this, we can start an execution from here again because of the toolkit support. And now when we go back to our parent workflow, we'll see that it is running, Forrest Gump style. Why? This is good. This is good, right? It's waiting. We're in that wait state right now, the first one. And we can see this from our execution history, right? So we enter the succeeding child workflow, schedule it, start the succeeding child, submit it, succeed the succeeding child, and exit. So that's as we expect, right? But the failing child failed. Now notice in this case, exactly 20,000 milliseconds later, we reschedule that retry. So now we got to wait 40 seconds for a total of 1 minute of execution on this. And we'll see that it will do one last retry, fail, and come back through the task failure feedback. So when we inspect this state right now, we don't have any output yet because the state is still in flight. Same thing for the parallel state, but the succeeding child state has given us back all of this information, which we didn't have before, because we're actually getting back the result from the succeeding child instead of the start execution output object, right? So we see what we expected to happen happened here. We've got a caught error notification, error states.task failed that we sent back, the cause, all this stuff that we set up. So this is working. English lesson by AWS Educate. That's right, Matchy Man. So this is working as expected now, right? And then in the definition, we see that all this information coming back from the nested workflow is a JSON string, right? Well, a couple things to know about this then. That limits us from processing state and sub-objects within there. But with 2 minutes left to go, boy, do I have something to tell you about. Today, we just released an updated version of the synchronous integration. As I was prepping for this, all you need to do is tag it as sync:2 for the second version of that task. The docs will catch up with this in a minute, but I've been told that it's okay to share this with you. If it's not, it's too late. I've already shared it with you. So we make both of these version 2 of the workflow. And then what happens when we deploy this is instead of a stringified JSON response, we're actually going to get back a JSON object response, which is huge because now you can reach down into the response object from your nested workflow and make decisions based on that response object, whether it's with a choice state or a pass state, without having to do any munging of that data that comes back. So we're going to execute this one last time in the minute that we have remaining with an empty object. And So we'll see that we're still running here, but that's okay because the succeeding child state has already finished. And in comparison now, we see a beautiful object. Look at that object, y'all. There's not a single backslash in this entire object. So right there, right at the buzzer, 2:59 p.m. Eastern, 11:59 a.m. Pacific, object support in nested workflows for AWS Step Functions. Again, the reason why you should care about this is it allows you to make choices now based on the results of those outcomes, because that has come back as an object and not a string. So all the JSON path processing stuff that we've shown you in previous episodes, that all becomes unlocked now for your nested workflows. So really, really powerful integration now. It's 3 o'clock. 8 p.m. in London. That's right, Julian Wood. And he's so awesome, y'all, for joining me to help out with mod support at 7 to 8 p.m. in London. So again, there we go. And we see that this continues to execute. We see the same output for our, well, maybe not for our failing child. I don't know what happened here. That might be a fallback thing, or it might be a versioning thing. But we'll see. As I said, we're rolling this feature out. So wait for the docs to catch up with this. Should be this afternoon. Very exciting functionality now. Again, I'd like to thank you all for joining me for the series. This is the 8th and final planned episode of AWS Step Functions on the AWS channel. I will be back Thursday for the final planned episode of App 2025, where we build an entire serverless application with service integrations, the pattern of the future. Again, we'll be doing Amazon Athena, so you can do your analytics pipelines with data that's stored in S3. Great episode. Again, it's been a ton of fun being here with you all, interacting with you. Please continue to send me your questions via DMs. DMs are open on Twitter. You can find me here. I will be back after a little while. I'm going to take a little break to sort of formalize some of this content and get it into more digestible patterns and tracks for you, but I'm not going away. The next series that I hope to do should start around July. A little too early to announce, but again, follow me on Twitter and you'll see the announcement. I'm excited about it because it's some of the biggest and longest running patterns that we've had at AWS. So very excited for that season. Of course, it'll all be serverless because I am, in fact, a serverless developer advocate. So again, thank you so much for joining us. I hope that you've learned something today. I hope that you go out and build with nested workflows and the composability and the newly released Sync version 2. All right. Thanks, y'all. Have a good one.